Ever get a whiff of that particular smell in some protein powders? You know that fishy one?
Yeah, I know exactly what you mean.
Well, this week, your sources are all about tackling that smell, and it all comes down to fish protein hydrolysates.
Oh yeah, fish protein hydrolysates.
They're super nutritious,
They are.
but they can have that fishy aroma sometimes.
Yeah, it's all because of this molecule trimethylamine, or
Yeah.
TMA for short.
TMA, right.
And these hydrolysates, they come from parts of the fish that might otherwise just be wasted.
Makes sense.
So it's a really sustainable protein source, you see. If we can figure out how to deal with that smell, we could be looking at a protein revolution.
So that's what these scientists are working on, right?
Yeah.
What's the secret weapon they're using?
It's an enzyme, actually, a special kind called trimethylamine monooxygenase.
Try saying that 3 times fast.
Right. We usually just call it TIM.
Tim, okay.
And what does this TIM do?
Well, think of it like nature's own deodorizer.
For fishy smells, specifically. Yeah, pretty much. It converts the smelly TMA into something called trimethylamine N-oxide, or TMAO, and TMAO has no smell at all.
So you're telling me there's a tiny chef in my protein shake making sure it doesn't smell like, well, fish.
Basically, your sources this time focus on one specific TM called mFMO.
mFMO. Catchy. Where does it come from?
It comes from a type of bacteria, Methylophaga aminisulfidivorans.
Okay, remind me again, bacteria aren't always a bad thing.
Right. A lot of them are actually super helpful. Think of them like tiny little factories producing useful stuff, including enzymes like our friend mFMO here.
All right, so we've got these sustainable fish protein hydrolysates, great nutrition, but sometimes a fishy smell. Then we've got this mFMO that can make the smell go away. Sounds like we've solved it. What's the catch?
Well, there's a bit of a snag. You see, mFMO works best at a specific temperature,
Okay.
but the processes used to make those protein hydrolysates often involve much higher temperatures.
So it's like having a delicate chef who can't handle the heat in the kitchen.
Pretty much.
So the problem is getting mFMO to work in those hotter conditions. But is that even possible?
It is. These scientists use something called the PROS algorithm. It stands for Protein Repair One-Stop Shop.
PROSS.
Okay.
And what does that do?
It basically helps re-engineer enzymes to make them, well, tougher, more robust, It's like giving them a heat-resistant suit so they can work in those hot protein-making factories.
So they basically upgraded mFMO so it could handle the heat. Did it work?
It did. They created several upgraded versions of mFMO, actually, and all of them were able to handle those higher temperatures much better than the original, some of them by almost 9 degrees Celsius.
9 degrees. Wow, that's quite the improvement. Any of these standout stars among those upgraded versions?
Oh yeah, there was one, mFMO 20.
mFMO 20.
This one was a superstar. Not only could it take the heat, but when they tested it with salmon protein hydrolysate, it actually reduced that fishy smell by a whole 95%.
95%? That's amazing. At 65 degrees Celsius too, right?
That's right. And it was just as efficient at converting that TMA as the original.
So we've got this amazing, smell-busting, heat-resistant enzyme. What could possibly go wrong?
Well, there is one more hurdle. mFMO needs a little helper to do its magic, a molecule called NADPH.
NADPH.
And the thing is, NADPH is really expensive.
So like needing some rare ingredient to make it all work. Not exactly cost-effective.
Yeah, that's the bottleneck right now.
So where do we go from here? Are we stuck?
Not at all. Scientists are already looking into ways to tackle this, maybe engineer mFMO so it can use a cheaper molecule or develop a system that can recycle the NADPH, make it go further. It's all about making this breakthrough actually, practical.
That's fascinating stuff. But before we get too far ahead of ourselves, let's take a step back. How does this mFMO actually work? What are the key things to know about it?
So remember, this mFMO comes from a bacteria that lives in the ocean.
Right, Methylophaga aminisulfidivorans.
Yeah, that's the one. And it actually uses, simple carbon compounds from seawater for energy.
So it's like this little swimmer munching on carbon snacks.
Yeah, something like that. Its name even means eater of methyl groups.
That's pretty cool. And the fact that it lives in the ocean, that tells us something about how mFMO works, right?
It does. Remember how mFMO needs that helper molecule? NADPH.
Yeah.
Well, NADPH is involved in tons of processes in living things, especially when it comes to energy. So it makes sense that a bacteria living in the ocean would have an enzyme that uses NADPH,
Okay, I get that. But how does mFMO actually get rid of that fishy smell? What's going on there?
So mFMO is what we call a monooxygenase.
Monooxygenase.
Which means it takes an oxygen atom from the air and adds it to the TMA.
Okay.
And that extra oxygen atom, it changes TMA into TMAO, which, like we said, has no smell.
So it's like mFMO is a tiny welder attaching an oxygen atom to the TMA, and poof, no more fishy smell.
Uh-huh. Yeah, that's a great way to put it.
And remember how we talked about mFMO needing that specific temperature to work its best?
Right.
Every enzyme has like a Goldilocks zone.
Yeah.
Not too hot, not too cold.
Exactly. Just right for it to do its job.
And that's where the PROS algorithm comes in, right?
Yeah.
To engineer a version of mFMO that can work in those higher temperatures. For food production, I mean.
Exactly. By, tweaking the enzyme structure a little, they managed to shift its Goldilocks zone to a higher temperature. Basically gave it a little heat shield.
Pretty impressive stuff.
Yeah.
Makes you wonder what other enzymes are out there just waiting to be, discovered and put to good use.
Oh, I bet there are countless enzymes hidden away in nature with potential we haven't even imagined.
And with tools like PROS, we can actually fine-tune them to work even better.
Exactly. It's like we're unlocking this whole new toolbox for solving problems.
Thinking of problem solving, those fish protein hydrolysates, they're not just good for the environment, right?
Yeah.
They're actually good for us, too.
Absolutely. They're like a nutritional powerhouse full of essential amino acids, the building blocks of protein.
Right.
And they're a good source of peptides, too. Those shorter chains of amino acids that can have a bunch of health benefits.
So they're sustainable, packed with protein and all this other good stuff. A win-win-win.
That's right. And, this research into TMAO, it's just the beginning. Scientists are exploring so many different ways to use enzymes to make our food healthier and tastier and more sustainable.
It's wild to think that something so small, like an enzyme, could completely change how we produce and consume food.
I know, right?
I bet some people listening are thinking, okay, this is cool and all, but what does it really mean for me? What's the big takeaway here?
Well, I think the main thing to take away from all this is that we're in a really exciting time for food science.
It really feels like
I mean, we're learning how to use, the power of nature.
harnessing nature.
Yeah, exactly.
Yeah.
And in this case, it's enzymes to make food that's good for us and good for the planet, too.
It's a great combination.
Imagine a future where we could enjoy all the benefits of fish protein, all the good stuff,
The nutrition, yeah.
but without that, strong fishy smell.
Yeah, that would be a game changer for a lot of people.
And that's what this research is. It's bringing us closer to that,
It really is amazing to think about how these tiny, invisible things, enzymes, could revolutionize food.
It is. And it's not just about food either. This research is a part of something much bigger,
What do you mean?
I mean, it's part of this whole trend in biotechnology, you see.
Okay.
Scientists are using enzymes to develop all sorts of things, from new medicines to, more sustainable ways of manufacturing.
So this deep dive into getting rid of that fishy smell has actually given us a glimpse into the future of biotechnology in general.
Exactly. And the possibilities are, well, they're pretty mind-boggling.
Give me an example.
Okay, so imagine personalized scents or perfumes created using specially engineered enzymes.
Okay, yeah.
Or we could even use enzymes to break down pollutants, help clean up the environment.
No, that would be amazing.
It really would. It seems like we're just scratching the surface of what's possible with enzymes.
Absolutely. The more we learn about them, the more we can do with them. It's exciting.
Oh, it is exciting.
So for our listeners who are, feeling inspired to learn more, what would you suggest they check out?
Well, if you're interested in enzymes, there are tons of resources online,
Yeah, for sure.
Start with the basics, like how enzymes work, then maybe delve into specific types, like the ones used in food or biotechnology.
Makes sense.
Oh, and there are a bunch of fascinating articles and videos out there about the latest breakthroughs in enzyme research, too.
Definitely worth exploring.
It really is. Who knows? Maybe one of our listeners will be inspired to make the next big discovery,
That's what we love to hear. Well, this has been a fascinating deep dive into the world of enzymes and their potential. I mean, they could really change the world. Thanks for joining us, everyone. Be sure to tune in next time for another exciting exploration of, the cutting edge of science.